Three.js is a JavaScript library to render 3D graphics on a website. We are going to see the very basics of Three.js that you will need to start using it. Here I have a Vite project to handle dependencies. So we will install Three.js using npm with the command npm i3. In our HTML we need a canvas element with a id canvas, which will be used by Three.js to render the 3D graphics. Then we have some CSS here to make the canvas element stay at a fixed position. Now let's begin with Three.js. First thing you need to do is import everything from the library S3. There are three things that you will always need in your project, which are scene, camera and renderer. A scene is like a container for the 3D objects and lights. For example, you can have a forest scene that holds 3D objects like trees, plants, mountains, etc., which you can use as a background for one section of your web page. Then you can have another scene that has objects like buildings, people, road, etc., that can be the background of another section of the web page. To create a scene, instantiate it using the scene class. Then we need a camera. Camera is basically how we see the scene, like from what angle, from what position are we looking at the scene. There are different types of cameras you can use, but the most common one you will be using is perspective camera. When using this, objects that are far will appear smaller and objects that are closer will appear larger, just like how we see. It takes 4 parameters. First is field of view. It is how much of the scene is visible at once from the camera. The value is in degrees. Second is the aspect ratio of the camera, which we want to be the same as our Windows aspect ratio. We get it by dividing the inner width and the inner height of the window. The other two parameters are near and far clipping plane. These two values are used by camera to render only those things or objects that are at a distance between near and far value. Anything outside of this range won't be visible. It's useful for optimizing performance, as rendering everything will cause performance issues. And the last thing that we need is a renderer. Renderer is what actually draws the scene on the canvas element. So just instantiate the WebGL renderer, and we can use an object to pass in some parameters. For now, all we need is the canvas element, which will be used to draw the scene. Then set the size of the renderer, which we want to be the same as our browser window's width and height. So it will cover the whole area and also position the camera on the z-axis. By default, anything added to the scene is positioned in the center, so we need to bring the camera away so that we can see things properly. And at last, call render method and pass in the scene and the camera. So this is the basic setup you need. Now we can start adding objects. So to create an object, first you need to define its geometry, as in the shape of the object. For example, we have box geometry, sphere geometry, cylinder geometry. Let's create a simple box for now. We need to pass in width, height and depth in the parameters. Second thing you need is the material. Material is basically how this object will look like, as in the color and texture of the object. We will use mesh basic material. If you use this material, you don't need to add light to see it. We can pass in an object to define its properties like color. Let's just make it white. Then we can create the actual object, the box, using the mesh and passing in the geometry and material to it. Then just add the object to the scene. We need to call the render method again to see the changes. And there we have the box. Now you don't have to call this render method every time you make any changes. We can actually create an animate function and call the render method inside of it. Then use the set animation loop from renderer and pass the animate function in it. This will call the animate function before every screen repaint. So now you don't have to worry about calling the render method every time you make any changes. Now on the box, you have a position property which you can use to change the position of the box on X, Y and Z axis. We also have rotation. Let's increment it on the X axis in our animate function. It will create a spinning animation on the box. This will keep incrementing the number endlessly, so it's not something you will be doing, but this was just for the example. Now let's talk a little more about materials and textures. There is a wireframe property which you can set to true, and it will give you the wireframe of the geometry that you are using. It's helpful to clearly see what the geometry looks like, or you can use it as a visual if that's what you are looking for. So this material doesn't interact with light, it's just visible. So when you do need the light interaction, you can use the mesh standard material. Remove the wireframe and the box just disappeared. It's there, we just don't have a light source. To create a light source, we just instantiate one of the available lights called point light, which emits light from a single point in all directions. It requires the color of the light, and you can also pass in the intensity. Then simply add it to the scene and position it away from the box. Now the box is visible. If you want to see where this point light is, we can use the point light helper. Instantiate it and pass in the point light. Then just add it to the scene. Now you can see where the point light is. There is one more light I want to show you, that is the ambient light, which lights up all the objects equally. This won't create any shadows as everything lights up equally. Now there is a really helpful feature called orbit control. To use it, you need to import it from the add-ons. Then just instantiate it with the camera and the renderer DOM element, and call the update method in the animate function. It allows you to navigate your scene using your mouse. Click and drag to orbit around the center, mouse wheel to zoom, and right click and drag to pan around. Now let's see textures. How do we give texture to the box? Let's make this box look like a wooden block. To do that, we can take the image of the texture we want and simply lay it out on this box. We call this texture mapping. So to actually do this in Three.js, we first load the texture using a texture loader. Then use the load method with the path to the texture image. Now we can put this texture on the box using the map property on its material. Just set it to the texture that we loaded. Now this will put the same image on all sides, which is fine if that's what you want. But if you need different images on all the sides, you need to pass an array of multiple materials, with each material containing the texture image for each side. Let me show you. So we have this array of images of different Pokemons that I got from Poke API. We will put these images on the different sides of the box. So for each image URL, load the image, then create a material and put this texture in this material's map property. Then just push this material to this array. So now we have a material for each side of the box with a different image. Just pass the materials array instead of this single material, and that gives us a different Pokemon on each side. We have Pikachu, Charizard, Venusaur, Blastoise, Magmar and Gengar. So these are the very basic things you need to know about Three.js. There are a few more things that we'll learn, like responsiveness and loading a 3D model instead of creating these basic shapes using code, which we will see in the next video.